All right, let's take a look at practice problem number three. This one is similar to number two, but a little bit different. So let's take a look at it together. So in this problem, you're asked, could a molecule of phosphotyrosine be used as an energy-rich metabolite, which is really just short for an energy-rich molecule that could be used in a way to replenish ATP from ADP? And then we want to explain the reasoning to show that we're not guessing. Okay, so similarly, to what we've done before, we can see that the synthesis, or really the addition of this phosphate group to tyrosine, that has a positive delta G value. So that's going to be an endergonic, non-spontaneous process. Um, and down below, just like above, if we add a phosphate group to arginine, that's also going to be an endergonic non-spontaneous process. How do we know? Again, a positive value for delta G. Well, we know in the problem that we're trying to replenish ATP from ADP. So this reaction is exactly what we want. And we want to leave it like this because that's what we're trying to do in this process. And like above, since we're putting these molecules together, this is an endergonic non-spontaneous process. But the question is asking us to consider, could phosphotyrosine be used as an energy-rich metabolite? Well, if we're going to use phosphotyrosine, we're going to need to flip that top reaction around. So I'm going to abbreviate phosphotyrosine going to tyrosine plus phosphate. So I'm breaking it down. It's going to change my delta G value from positive 10 to negative 10. Okay, so it's an energy releasing process. And I'm coupling that, right? I'm associating that with the reaction for ATP synthesis, which is shown above, but I could certainly write it down below if that is helpful. Delta G there is 30 kilojoules. So if we sum those two values together, we can see pretty quickly that we're going to end up with 20 kilojoules. That's a non-spontaneous endergonic process. That's not energetically favorable. So what that's telling us is that even if I were to break down phosphotyrosine and use that phosphate group as a source of biochemical energy, there isn't enough energy stored in that phosphate group if I were to transfer it to ADP to make ATP in an energy efficient manner. So phosphotyrosine is not going to work. Now, interestingly, if we look at phosphoarginine, if we did the same thing with this second reaction with its positive 32 kilojoules per mole, if we flipped that reaction, we'd end up with negative 32 kilojoules per mole, and that would actually give us enough energy, just barely, if you will, to make the overall process spontaneous or exergonic. The delta G there would be negative 2 kilojoules per mole, and I would encourage you to test your understanding of that by working out the process just like I did for this problem.